Hey guys, what's up? Let's see, can y'all hear me? Let's see, can y'all hear me? You can, alright. It's been a little while. Let's see. Oh, Windows is trying to do an update here. Sup, 8-Bit Life? How is it going? Alright, so tonight we're finally doing the N64 Jewel install. I've been working on this project for a while. Well, I say working. It's more like I finished it and then it's just been sitting on the back burner, not getting released for months now. But I finally got other stuff sorted out, so I'm gonna go ahead and do the demonstration on this so that I can then write up documentation, which then I can use to ultimately release this. So I want to do a quick little history lesson on N64RGB mods to try to give some context for what this is and why it exists. So way back in the day, there was Tim Worthington, and Tim Worthington, you might know him. He created a universal N64 RGB mod that worked for all N64 models, whether they had the RGB DAC inside of them or not, which was kind of groundbreaking for N64, because it used to be that only the earliest revision N64s could actually be RGB modded, because the early models had an RGB DAC, but they did not have, but the later models, they removed the RGB portion of the DAC. So when Tim came out with his N64 RGB mod, that enabled it's actually a DAC that converts the digital signals from the N64 into analog RGB. So that allowed all N64 models to be RGB modded. After that, Bordy 4938 came out with his own spin on Tim Worthington's design. This is my revised version of Bordy's design, but basically it's the same concept. It uses the CPLD to basically convert the digital signals into analog signals using this resistor ladder DAC. So that's basically what Bordy's design was. It's just a more compact version of Tim's design, and it was open source, so anybody could make them. I started making these, I don't know, like 2016 or something. And one of the problems with these boards, Tim's early boards as well as Bordy's early boards, was that the N64 has a really noisy 3.3 volt power rail, and noise from the audio amplifier circuit would actually end up in the video signal for these early RGB mods, and it would cause the video brightness to flicker as sound was happening. So if you had really loud sounds happening in the audio channels, then you could see flickering on the screen. They solved that by integrating a separate 3.3 volt regulator to power the RGB boards that ran off of the 12 volt rail of the N64. Later on, I took Bordy's design and integrated a 12 volt to 3.3 volt regulator directly into the board, so that it was no longer a separate piece. And this is the one that I've sold for years and years. It works really well, but it's kind of a pain to install just because of the kind of the old school way that this was designed to be installed with ribbon cable and stuff like that. So that leads us to today. what we have here is my new N64RGB mod. Now this still runs the firmware from Bordy's N64RGB mod, but I've completely rethought how the form factor on this works. This board is designed to fit on top of a Retro GEM. So that way you can easily dual mod an N64 with both a Retro GEM for HDMI and this N64RGB Jewel for RGB output. So you can have both RGB and HDMI at the same time. It also can be installed standalone. So this would effectively, you can consider this a replacement for my older N64RGB mod. And I have a flex that I designed for standalone installation. So this flex you would just solder it into the N64 just like you would a Retro GEM flex or something like that. And then it just connects to this connector at the back of the board. And then you have your AV out board, which connects to the AV out. And then that connects to the board right here. So basically everything is flex cables now. So you don't have to solder the individual wires. You just solder the flex cables into place and then you're done. This also, the way that it works on the Retro GEM is that it sits on top of the Retro GEM. The Retro GEM's flex cable installs on this long connector here, and then this little short flex cable installs right here, and then it folds underneath and plugs into the Retro GEM. So you actually, when you're installing this on a Retro GEM, you're using the Retro GEM's flex cable. So you don't have to solder in an extra flex cable for the Retro GEM. It's already there. So we basically grab the signals from the Retro GEM flex cable to make RGB, and then we send the rest of the signals back out so that it actually goes to the Retro GEM. So it's almost solderless, but you do still have to solder in the AV output. So it's not completely solderless. But anyway, that's the general overview of what this is. Let's go ahead and get started on one of these consoles. So we have an N64 here. This already has a Retro GEM installed. We'll do a quick function check here. And there you can see we've got our EverDrive. So this Retro GEM is already fully installed. Now this, I also have the clock mod done on this Retro GEM as well. So it is controlling the clock signal on this N64. So now that we've shown that this is working, let's go ahead and jump back over to the main camera, and we will go ahead and take this thing apart and get the Jewel installed. All right. Just remove all the screws. Okay. So for the Retro GEM, you have to remove the top heatsink because the mounting screws for the Retro GEM are actually underneath the heatsink, and we need to have access to those. But we also need to completely remove the motherboard because we're going to be soldering to the AV out connector on the back side here. So we need to be able to flip the whole thing over. So we're just going to go ahead and remove the entire motherboard right now, and we'll go over how to put it back together once we get through here. So you basically just remove every screw, pretty much every screw you see. Let's see. Okay, now the 3D printed mount that comes with the Retro GEM is too thick for the Retro GEM and the Jewel to fit underneath the heatsink. So the Jewel kit is going to come with a thin 3D print. You can see the thickness is way less. So there's a thin 3D print that will fit both boards. Also, the thermal pad that goes to the heatsink will no longer reach the heatsink on the on this design, because the Jewel will be sitting on top of the Retro GEM. So this mount also has a cutout in the bottom that's right underneath the FPGA for the Retro GEM that allows the thermal pad to transfer heat from the board down into the shielding of the N64 instead of the heatsink. This should be plenty of heat dissipation, because the thermal pad to the bottom of the board is how it's done on a few other Retro GEM kits. So no real worries there. All right, so the first thing we're gonna do, now that we've got this all opened up, is we're going to flip over. Now this is a CPU O2 board. That's important when we configure the jumpers for this AV out. So we've got our AV multi-out. We're just going to take one of these multi-out boards, quick solder boards, and you just install it in place like so. And then we're just going to solder all of the points that need to be soldered. All right, so that's all the points that actually needed to be soldered. That's all the vias that that are actually plated. Now, there are a couple of jumpers on here. If we look, you have a few different options here. So on these early N64 motherboards, they're going to have, let's see, C22, R1, and R14 are often, they're usually going to be populated on these early, like CPU 01, CPU 02, possibly CPU 03, I can't remember. Definitely not CPU 04. But these early ones, they're going to have these resistors and capacitors populated. Those are for C-Sync. The early boards, even though they didn't actually have RGB, they did have C-Sync wired up. So what your options are either to, if you don't have these resistors here, then you can close this jumper labeled C-Sync here. That'll bring C-Sync from the RGB mod to the multi-out. If you do have these resistors, you have two options. You can remove R1, R14, and C22 and then close the C-Sync jumper, or you can leave those resistors and capacitor in place and not close the jumper. The difference here is whether or not the RGB mod is the one generating and sending the C-Sync signal to the AV multi-out, or if it's the N64's own built-in DAC that's sending that C-Sync signal. It doesn't really matter because this mod doesn't do any line multiplication or anything like that. So the C-Sync is valid. The C-Sync signal that the N64 DAC generates is valid for this modded RGB signal. So it's really up to you whether or not you want to do this. For these early models, I will just leave the resistors in place and leave the C-Sync jumper open. Now the other jumpers we have up here are the composite and Luma jumper. That's a special option if you want to send C-Sync signal down the composite or the Luma pin instead of the actual Luma signal or composite video signal. Most people wouldn't want that. I don't really recommend that, but it's there if you need it. Basically, if you want to send the C-Sync signal down the composite pin or down the Luma pin instead of sending composite or Luma, you just remove the components for whichever signal you want to disable and convert into C-Sync, and then you close either the comp side of this jumper or the Luma side of this jumper. That's really all there is to it. So in our case here, we're not going to close any jumpers. We're just going to flip everything back over and start putting it back together. And our Retro GEM Flex cable is just going to stay exactly where it is right now. We don't have to do anything special with the cable. It's already where it needs to be. All right, get our shell back. Still have our Retro GEM kind of hanging out here. So, to install the Jewel, let's see. Okay. All right, so to install the Jewel, first thing we're going to do is we're going to take our new 3D printed bracket. We're going to go ahead and pop the screws into that. Okay, so our new 3D printed bracket is in place. You want to check with your finger just to make sure that there's no burrs or anything like that sticking up from the screw heads, because the clearance is really thin on this thinner 3D print. So you don't want them puncturing the solder mask on the Retro GEM. So just make sure there's no sharp edges coming up. We take our thermal pad and we just pop it right in here in the little notch there. And then we take our Retro GEM. And we're going to install one screw on our Retro GEM, but not both, just one for now. So we install the screw here by the HDMI port. Okay, now for our Jewel, we need a spacer that sits right here over the second screw hole, and then we need to get our GEM flex ready. So this is the flex that connects the Jewel to the GEM. So we're gonna go ahead and we're gonna go ahead and pop this flex into here. Okay. And then we're going to pop this end into the Retro GEM. And then you'll notice that the new flex cable clears the screw hole here, so you have space to work. You just fold the Jewel over, and then you take the screw that I would include with the kit, this extra long screw, and we install that through the spacer and tighten it down like that. So now the Jewel is firmly attached at the edge of the GEM. It's held in place by the edge of the HDMI connector. It hangs out right here behind this ledge, and then the rest of it is pressed up against the edge of the shielding for the N64, so that's how it stays kind of locked in place. Then we open this latch up, and then we can install the Retro GEM's flex cable. Just like you would on a normal Retro GEM install. And then we just need to attach our RGB cable for the multi-out. Okay, and then you just kind of route this cable underneath here. And that's it for connecting everything together. So then you're just going to pop your heatsink back on and reconnect your Wi-Fi cable. And then you just got to get your screws back in. Now what I'm going to do here real quick is I'm just going to pop a couple of screws into the heatsink, and then we'll do a test run, and then we'll put everything back together. It's always a good idea to do a test run before you fully reassemble. Okay, let me grab a jumper pack and a controller and power. Okay, I'm going to test RGB first. So we're on the RetroTink 5X right now. Okay, let's load up some Mario.
me, Mario. Hello. Okie dokie.
Okay, now, as far as features are concerned, this mod taps into the digital video signals. It also taps into the controller signals. So the Retro GEM takes samples the controller signals for player one to do menu controls and stuff. Well, this also is able to sample the controls to do IGR stuff. So one of the examples is if you want to turn on or off the deblur setting, which this has. If you hold down Start, Z, and R, and then hit either the left or right C buttons, that'll turn deblur on or off. You can also enable or disable 15-bit color. And then you can actually do a full reset of the console by holding down Z, R, Start, A, and B. And that does a reset. So that's the RGB mod working. Now let's unplug the RGB and plug in the HDMI. So you'll be able to see that the GEM is also working. So now we're on the GEM with HDMI as well. And we can access the GEM's menu and make changes and settings and stuff like that. So this is all simultaneous, dual simultaneous output of RGB and HDMI. And it's a really easy install. If you already have a Retro GEM installed in your N64, this install is one of the easier installs you could possibly do because you're only soldering to the AV port, so it's not really a challenge to get that right. All right, let's go ahead and close this one back up. And then we'll move on to the other install method, which is the standalone install, in case you just want to install this into an N64 without a GEM and just use it as an RGB mod. Okay, the heatsink's reinstalled, and you can see that this board clears the heatsink. Just a little tiny gap. But yeah, it's pretty tightly sandwiched in there. But yeah, and then also, if you need to get to the button on the Retro GEM to reset it or access the diagnostic menu or anything like that, you can actually press it by just pressing down on the Jewel board. It's positioned over the switch, so if you just press it, it'll flex the board just a little bit and push the button. So you still have full access there. All right, let's see. Sorry about that. Let's see here. We need to get these screws back in. All right. That's it. So there you go. There's a Retro GEM and RGB modded N64. And you really can't even tell that there's anything special about it. It just looks like a Retro GEM mod because you can't really see what all's going on in there. You just one extra flex cable. So this N64 is actually going to be for sale pretty soon on my website. This one will be for sale, and then the one I'm about to do will also be putting up for sale. So if you're interested, should be there soon. All right, the next one we're gonna do, this is just a like a early N64, Japanese N64 that I swapped into a new production shell. This does not have a gem in it. This is just going to be a standalone install to show how to install this if you're just using it as an RGB mod and not doing the dual mod with the gem. So, go ahead and pop this one open. Okay, same as last time, we need to remove the board and we need to remove the heatsink. So we're just going to go ahead and pop all the screws out. All right. So for this one, we're going to be soldering straight to the RCP. And we're going to be using this flex cable. It's similar to a GEM flex cable, similar design, but it has less pins because we don't need to collect any of the audio signals for the RGB mod because it's still analog, so it still uses the existing analog output from the N64. So if you look here, the flex cable actually tells you which pins it's soldered to. So it starts at pin 10. And if you look down here, let's see. There we go. All right, so if you look down here, you can see we start off at pin 1. So we got pin 1 here, then pin 5, then pin 10. So this flex cable needs to be soldered starting at pin 10. Just like that. And then you'll see you've got a ground pin right here, which lines up with this ground pin here, so you know for sure you're on the right one when you get it on there. So we're gonna go ahead and solder this in. Now what I like to do is I like to hit the RCP with a little bit of flux. And then I like to come in with a tiny amount of solder. Tiny amount of solder on the tip. And then just come in here. And basically we're just tinning up the RCP with some fresh solder. Then we clean our tip really good. And we just come back in to make sure that we don't have any shorts from where we tend. And looks like we do not. So we are nice and clear. Then hit it with just a little bit more flux. Get our flex cable positioned correctly. Right here. Then we'll just tack it on one side there. Then we'll come back over here to the other side. Tack that, and then we can start working our way through. Well, that was too much solder, so we're gonna go ahead and get the knife tip back out to clean up the excess. Should be pretty straightforward here. And it was. All right. So there is our soldered flex. Come back in at a better angle for me. Just want to touch it up just a little bit. Okay. We'll hit it with a little bit of alcohol. All right, so now we need to install our controller and reset cables. We just have these two pads. We're just gonna run a couple of wires down to the locations we need them. So, control, reset. Okay, so control is gonna be on pin 16 of the PIF. And then reset's going to be on pin 27 of the PIF. And we're just going to use a little bit of Kynar wire to connect these. Okay, we'll go ahead and just install the wire to the PIF. And we'll do the same thing for the reset wire on the PIF. And then we'll actually fold them over and get them positioned the way we want them. And then we'll trim them back. Okay, so now that's done. Now the only other thing we got to do is we need to put a little bit of Kapton tape on here to prevent any potential of these pads shorting out. Actually, we'll go this way. There we go. All right, and then our flex cable is just going to fold like this so that it can pass up over the AV output. All right, let's go ahead and pop our shield back on. All right, and then on the back of this board, let's check and see. Okay, this one does also have the resistors, so just like last time, we're gonna leave those on there. And we won't be closing the C-Sync jumper. I'm just gonna solder all of the pins that are actually plated through holes. And that will connect everything that needs to be connected. like so. We can put our rear shield back on. Okay, and that's pretty much all there is for soldering. So now we just need to reassemble everything, and then we'll install the Jewel on its mount. Alright, so just like last time, the Jewel mount goes right here. You just need a couple of screws to mount it. Oh, sorry about that. Jewel mount goes right here. You just need 2 screws to mount it. All right, and then you take your Jewel, and this flex cable goes into the rear connector at the back, like so. So then you want to fold it over to where that basically you have this loop, and then you can kind of press that, kind of fold it. It's a little origami. If you've ever done a Retro GEM, you'll be familiar with the origami. But you just kind of fold it over, and fold it over, and fold it over to where that it sits kind of like that. So fold, 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 then you're done. Now, just like the Retro GEM version of the install, you have the long screw and spacer. Well, in this case, because there's no Retro GEM under here, we're going to put the spacer on the screw, and we're going to go ahead and screw the Jewel into the 3D printed bracket with the spacer in the way, like as part of, like on top of it. And that just basically allows the screw to not be too long to thread in and hold the board in place correctly. And then for the analog video signals, we just take our cable from the rear multi out, and we install it in our little FFC connector, like so. That's pretty much it. Now, you can fold these cables. I wouldn't get too aggressive with the folds, but you could fold the cables to make them a little tidier looking. That is up to you. You don't want to damage the cables, so don't like really pinch them down, but you can put a little fold in them like that so that they're a little bit more straight, a little bit more neat. Like so. It's not perfect, but you know, it's fairly neat. And this one doesn't need a thermal pad or anything because this doesn't really produce any heat. On the Retro GEM produces a fair bit of heat, so it does benefit from the thermal pad, but this mod doesn't need it. Okay, we'll just reassemble the heatsink and we'll do a test here in just a second. Before we get too far into this heatsink. All right, let's do a quick test of the standalone Jewel. All right. Let's see it. And there you go. There's the standalone. So this effectively is the replacement for my old N64 RGB mod. Excuse me. Okay.
Okie dokie.
There we go. So this basically is just a replacement for my old N64 RGB mod. It is a flex install, obviously, as you saw, instead of a ribbon cable install. And I believe that makes it easier to install. The ribbon cable, it can be it's less fine as far as the soldering you need to do, but I think in terms of actual difficulty, the ribbon cable, soldering the individual pins of the ribbon cable is more likely to be difficult for a beginner than a flex cable. Flex cables seem daunting, but they're actually really pretty easy to do. So I think this is going to be a better option for people than my old design. And then on top of that, you've got the Retro GEM Jewel Mod capability as well, which makes it so much easier. And then, of course, in standalone mode, it does have IGR, so you can turn on and off 15-bit color mode, you can turn on and off deblur mode, and you can reset with the controller. So that's pretty much it for that. Let's go ahead and put the rest of this thing back together. RG Dickinson. Yes, this has IGR. This is based on Bordy 4938's firmware. So it has IGR, it has deblur, which is it's got automatic heuristic deblur, which tries to basically guess whether or not a game needs deblur. Sorry, there we go. It guesses how whether a game needs deblur and tries to turn it on or off automatically, depending on the line count of the game. And then you can also manually toggle it on and off through the controller as well. And the IGR commands don't interfere with the Retro GEM's IGR commands. As far as I can tell, I haven't encountered any conflicts. I haven't encountered any conflicts between the two. I believe that the Retro GEM uses a totally different set of commands. All right. There you go. That one's done. This one's done. So, both of these N64s are going to be up for sale. This one has the Retro GEM and the Jewel. This one just has the Jewel as a standalone install. And then as far as the Jewel itself, now that we've done this live stream and I have video that I can use to collect reference images and write the documentation, I should hopefully have these actually for sale on my store next week. That's the plan. I should be able to write up the documentation over the weekend and then have these ready to go next week. I have about 30 of these built right now, so not a lot for this initial run, but I'm going to have a larger batch made shortly after releasing these. So does anybody have any questions while we're still here about the mod or anything else, except for about the scalable video switch, because I'm not fielding questions about that right now. It's been such a nightmare. Well, if you are a scalable video switch pre-order customer, or if you're somebody interested in buying as soon as they become in stock again, I do have another update I can give right now. They have solved the issue that I talked about on Twitter last time, where the end cap was getting stuck in the eject side of the mold, or in the non-eject side of the mold, to where the mold would open up and the end cap would pull out with the non-eject side of the mold, and that meant that they couldn't eject it out of there because there's no ejector pins on that side. So they fixed it by creating these extra, basically, pillars that go up into the eject side of the mold to create more resistance to hold that piece in the correct side of the mold. And they've been running test samples. They were going to try to ship them to me today, but I did not hear back from them about actually shipping them today, so it might be Monday when those ship. If those arrive on Monday, or, well, if they ship on Monday and arrive on Tuesday, then they should be approved by Tuesday when I receive them, and we should be then in full-scale production after that. So that would mean probably another few days to a week maybe before we receive the first shipment of the shells, and that means shipments of SVS modules are going to start going out. The invoices are going to go out, and then the shipments are going to start going out as soon as we start receiving them. So we are like right there. So that's pretty much all I have to say about the SVS. If you're not here for that, then now you know something extra that other people don't know. So looks like there's not really any questions about this, but I appreciate everybody for coming out. I know that we had somewhere around 20 people earlier on, which is always cool. If you have any questions later on after the live stream, you can always hit me up on Twitter. You can send me a message on my contact form on my website. If you are interested in purchasing one of these consoles or one of these Jewel mods, then you just want to keep an eye out on my website for the listing to go up for the consoles and for the RGB Jewel. But that's pretty much all I got for y'all today. I will catch you guys later.